Welcome to the Databricks Skill Builder series. We're glad you're here.
Hey everyone, Arthur Dooner, specialist architect at Databricks. I'm a specialist in AI and ML. So I'm here to talk about a lot of concepts that exist in building these AI systems, especially batch inference today. So these days at Databricks, we've been calling batch inference internally like intelligence engineering because the concepts are about taking all of the data intelligence that exists in your compute, in what you have already, and scaling that to be structured insights, reformatted insights, insights that are shared in an email, all of these sorts of new takeaways from source data where those insights used to be extremely time intensive or compute intensive or engineering intensive to materialize. So let me show you what I mean when I say batch inference, intelligence engineering, the like. So when I think about building batch inference pipelines, I think about all of the different documents that we all have in all of our organizations, from contracts to claims to regulatory policies to SEC filings that are available from the public internet, right? With all these like public reporting data that exist out there, from all of the tickets that all of your customers submit, from all of these insights with sentiment and social media. How do you pull that? That's a lot of effort. That's a lot of engineering historically with natural language processing strategies, like NLP for short, that you'll hear a lot of data scientists speak about. And now NLP technologies are still extremely fast, still extremely efficient, and really good at extracting certain types of data, certain topics, keywords, sentiments, right? But at the end of the day, we need to think about how can we democratize the capability of processing these large data sets to unlock net new insights. And oftentimes I see teams invest in NLP pipelines, those really efficient natural language processing pipelines, once they may have found that there's value in the data that they're pulling from this batch inference pipeline, right? So can imagine us getting sentiment out of these data, summarizing these data into reports for analysts and executives, building these historical data for analytics, personalizing communications such that it includes some shared context that everyone else gets, but from with some very precise recommendations for end users. There's so many ways that this data can be used in a scalable and useful way to help folks understand and get new insights out of. So, where do we go from here? We're all sitting on all of this data. And now generative AI with this batch inference technology allows us to scale this level of analysis combined against structured and unstructured data. It's a great point for folks to step into Gen AI. So if you're just getting started with Gen AI, thinking about how you can extract these fields, these are easier to implement than chatbot. There's fewer moving parts in this in this workflow, right? And there's direct value often. Like, hey, I always look at these docs and I look for these few things and I try to like extract these key terms. Well, suddenly AI can do that for you and save you a lot of time, right? So we think about Databricks as a platform, right? We think about it being the place where you are already connecting to, storing, processing all of your data, right? What better platform than to connect all of these data to all of these foundational AI models from Llama, Claude, GPT variants by OpenAI, right? All of these different models to this data at scale, right? So batch inference is when for every single record, and you think of every single record, a folder full of documents where each record is an entire document. It could be a raw binary like PDF document, but this is just a data set where every single record you're doing the same sort of processing against each record. So you think about all the information you're going to be extracting there, the data that you might transform from those documents, and the data that and the content that you generate from that. right? So we think about, hey, with this technology called AI query, we can concatenate, we can summarize all of these data, and we can say, what does this review really say in this example? It's very slow if you're just calling like the OpenAI endpoint one after another in a for loop. It's not efficient. It's not a good use of your OpenAI resources. It's not a good use of the compute that's running this processing, right? So where we think about with this with Databricks is we want to process these all at once with Spark clusters, calling all of these AI models in parallel, right? So on Databricks, how does this look? We call this function called AI query. And what AI query does, it allows us to take all of these ML models. Obviously, it's optimized for AI models like Claude, like Llama, like OpenAI, but it works on any Hugging Face model that you might want to attach to models that you might already have in Databricks for like regression classification, more legacy style AI use cases. Works with NLP models, right? So AI query is just pointing a served AI entity, a model, at every single record of a data set. What this does is you can see typically we attach a prompt like say, hey, we want you to extract, or we want you to summarize, or we want you to um, label, we want you to rewrite, we want you to do any of these things. The prompt is what guides that activity. The models on the right side, you're like, oh, fine-tuned to a specific use case. Now what Databricks has under the hood, we can fine-tune this data, this model against your data, and we can use these with the historical examples that you have to make a more optimized model that does that classification, summarization, labeling, so on and so forth effort more efficiently. And you'll see more of that capability announced at our Data and AI Summit in a fully managed way. And if you're watching this in the future, check out announcements from Data and AI Summit 2025 around batch inference. So the ways that this work, as I said, works with any model. It works in all of the data pipelines that you've already built. If you've, hey, I've been processing all these PDF forms, and now you can layer in an additional step to extract all of these insights over these PDF forms. And this runs at a mega scale, right? In a self-service way where anyone can just click through, run a couple commands, and now you're running these huge AI processing pipelines at against any data set you want to point it to, any unstructured data that you care about. So we think about these key patterns. We have this abstraction in Databricks called Unity Catalog. What Unity Catalog does is it's intentionally governing who has access to what data. So it protects and governs like the data, the compute, the different levels of Databricks that exist here, right? And we think about the information extraction that we might do over those data, the way we might transform these data, the content that we generate from a synthesis of this data. I know a few folks who work in marketing spaces, and they'll be building like custom emails, they'll be building custom reports, they'll be building custom mailers for all of these different consumers, such that they get these very targeted, specific references, discounts, deals derived from what we already know about them in our data model, and what we can offer them based on maybe physically their location. We can give a discount for that specific location, or think about the different ways that we could say, oh, we know that they own this car, we know we own this tractor, that sort of thing. We can give them a discount based on the vehicle that they have, right? We might be trying to ship more of a certain type of oil, and we have an excess, so we need to sell that faster. We can give people with the cars the right oil it could be provide a discount for. So that's the sort of flexibility and power that batch inference allows us. So you think about how you would have to do this on another platform. You'd have to connect to all this custom like filtering code, build it into a notebook, build all these OpenAI batch workflows. If you really want to be super efficient about this, you have to build like a custom parallel query orchestrator, and you'd be limited to the capacity by an endpoint, right? So, and you'd have to write it all, and you'd still have very little to no governance. over this whole workflow, right? So it can be a challenge when you're like, how do I put all of these data together? How do I make sure I don't have any performance bottlenecks when I don't have a lot of data or when I've got a ton of data, right? And how do I make sure I can handle like all of these data in one place and not potentially fragment a compliance strategy, right? I want to make sure everything is governed, everything is auditable. We know where all of these inferences are coming from. So our vision is to make sure that this is now provisionless. So now these models will spin up as you need them, right? Across different endpoints as people consume them, and it will be used just for them with that additional compute, so that rather than having to set up your own compute to do this, set up custom provision capacity for this like you would on Azure AI or historically would have had to do on Databricks. Now it's a provisionless offering where you just reference the type of model that you're looking for, and there's no additional setup. It scales to the amount of compute that you need. So now you've got the data that you've already been bringing, that's all governed. You have a model that scales to the amount of data that you need. And we think about how do we protect all of these different outputs from being in arbitrary formats or being framed wrong. What I want to highlight is that we now have this technology called structured outputs. So now you've got the data in one format, you've got the compute at the scale that you need it, and now you can guarantee the outputs of an endpoint are going to match to a certain strategy. And the way I mean that is that if you ask a structured output format data to return a specific structure, like, hey, what is, from this unstructured, I'm Lance and I like to bike. Hey, I'm always going to be looking for name and interest out of all of these different lines of text, right? Or these different rows, I should say. You can think about it as like, who's what, it will always extract the name and what they're interested in. So you can see from that schema definition, we're going to be pulling, these are the fields that we care about, and will force a JSON schema to always respond with that format. Okay? Why you would do this? When you're doing data extraction, I'm sure a lot of you know, as you were trying to get OpenAI and other models to do this for a long time, it would be trying to get all of these different workloads to conform to, you'd say to a model, get this in a JSON format or you're fired, sort of stuff, right? There'd be all these very silly prompts and over-engineering of prompts that people would do to force this sort of structure. So what Databricks did, Databricks and OpenAI both support this technology these days for structured outputs, right? Where we guarantee in these models, any of the models that Databricks supports, OpenAI supports this similarly, that we guarantee that we can return a JSON reliably from what we expect the model to generate. So it works great for all of these batch use cases, but it also helps guarantee consistent responses and formats from agentic systems as well, as you're attaching to tools, as you're calling databases, as you're parameterizing those calls. You want to make sure that the infrastructure of these things going back and forth is always consistent formats, so you don't get errors or errors that might crash the overall agent. You'd want to protect that sort of thing. So as I alluded to, you'd be using this for structured output generation. You'll be using these with agents. But what we want to highlight today is the batch structure generation side. So there is that future forthcoming technology that we have at Databricks, as I alluded to for Data and AI Summit, this thing called key information extraction. And this is soft launched with all of our offerings going into Data and AI Summit. There's still a few others that we will be highlighting. What it is called now is AI Builder. You can find public documentation on this. What this does is it helps us extract key information. So if you don't want to write the code to do this, you can specifically extract specific like text corpuses. You can describe the task, and it will validate it with a few of the outputs that you generate. And now all of a sudden you have that information available to you in a way that is consumable by end users. So you see these insights can be extracted in a renewable way, even in a codeless sort of structure. So as we dive in, right, I want you to see one of these examples on, one second. Let me stop sharing for half a second. And you can see yeah, okay, this is a pretty good example. I've got this scenario where I'm trying to understand, like, hey, tell me about all of these different, not to get too meta on any one person, but any one concept, I should say, but there's a scenario where I'm trying to personally understand how are my AI POCs going? How are the AI POCs and systems that I'm helping folks build working for my customers? And I take notes on how these working sessions go, right? And I really care about making sure that I can like summarize that to my business partners in a really aggregated way. And I can remember, oh, who is the customer players? What type of POC was this? Who on our side was helping out? What did the customer say worked well? And like their mandate, what are they trying to do? What was the focus of the POC? All these fields, right? And so what I do is I will say like, okay, this is the format, and then I include with this like Databricks source like private model, this Llama 4 Maverick, I can say, oh, get me all of these in a guaranteed format with all of these different fields, right? Insert, hey, if something's a list, like the products featured about Databricks from my notes, hey, that's an array full of strings, right? Like all the different products, right? So on and so forth, and it generates like a meaningful summary that helps me talk about retrospectives to my business partners and to my leadership. So you can see the value here where I'm getting, and all this is actually having to run is I'm running it in I'm concatenating a column, which is that prompt that I specialized, the columns, which are all the columns that I personally care about, which are like the notes about the use case, the notes about my request, that sort of stuff, right? And a prompt close signal, as you can see, right? And you can see like, okay, what are these concatenations? And let's take all of these together and let's say AI query Llama 4 Maverick over this, we end up with those really helpful summaries. So the whole point here is that we have a really reusable, consistent way of consuming data from an AI system, and it returns JSON that I can just parse back out and work with. So who's using this batch inference? Like how is this being used in across a lot of different types of customers? So I'm working with this tractor company that they have all of these technician notes. Like when people bring their tractors in for repair, the technicians will write up like, this is what's wrong, this is where there's an issue. And from these issues, and these are mocked up, right? I'm not sharing anything about this customer. Um, the idea is that it can identify when something is significantly wrong with the tractor and like identify like key types of failures. That's one consumption thing that we're looking to do so that they understand what types of failures exist on their tractors. But more importantly, there's a second level of, hey, people didn't mention that they needed this service soon or service now, but they mentioned that they need the service soon. They need brakes soon. They need to follow up on any of their repairs, that sort of thing. Well, we can just log that and we can use AI query, the batch inference technology, to say, tell me when service is necessary, or like which customers are most likely to need service soon against tires, brakes, any regular maintenance items. And we can send out mailers, email, whatever, such that we can discount those offerings to get people to come back to these tractor dealerships so that people will come back there rather than necessarily go somewhere else for their repair. Finally, before I conclude the time with you today, I want to highlight that's one really clear-cut example, but there are lots of use cases that people take intelligence engineering on. I see folks who have built I've been working with engine companies and embedded systems engineers alike to build co-pilots to help them understand what code files they might exist that might materialize, and like where different protocols they might need to change and all the implications of them changing a certain protocol, or how to use like custom modules in their code. Like, hey, how could a user implement or consume this package that we maintain? Those pieces all are read through, analyzed with batch inference, so we can understand the relationships between the C code, understand what each function in the C code does, have a high level kind of map of where all of the C code is being used and how it materializes in an English way that we could then look up and then consume again through a vector search. So you see, it's the first part of the AI systems, all the descriptions about the C code in this case. It's not necessarily we are just building an AI system and attaching it to C code. We're doing some processing to understand it better. Additionally, there are often product listings that vendors might not have all the context about, or they would have to join it in a really inelegant way. So expanding that product context from these wealths of knowledge bases they might already have, and then dynamically calling the knowledge base for each one for, say, thousands of products, can become effort prohibitive, cost prohibitive. There's a lot of engineering effort that goes into that. Not so much anymore with batch inference. You can call this vector search against this product database, find the most similar products that match colloquially or are similarly structured or have similar characteristics, and try to label all of those product metadata where there might be gaps. Often that one is still validated by a human, such that there is a way that we can say, hey, this is like a person in the middle saying, yep, this looks good. I know for a fact these attributes are right, but it's much, much faster of a process. And finally, before we call quits for today, is the graph rag scenario. So I have a lot of folks coming to me that are looking to expand retrieval augmented generation the way that a lot of foundational AI systems have been built. Retrieval augmented by, augmenting generation that we then run with a model, right? That retrieval is typically one stage. And when I say one stage, it is you have pulled in the context that you need from this endpoint full of, let's say, product information. And then that is the end of the retrieval and the end of the ability of the system to follow up without making another call to that vector search, right? In my take, these data can be much more deeply linked. I've worked with a couple aerospace companies who, as part of like maintenance workflows, have said, hey, I'd love to like help technicians understand how to repair these aircraft, but in a very like nested way, right? Like how do all of these systems relate? And what are the things, the progression of things that you need to either take off the aircraft to work on specific components that might be buried well within? That's one key example, but this goes a lot more broad, right? This can be applied to medical contexts, financial services, research. The domains are relatively limitless of these data relationships. So having graph entity relationships among these data is essential for deeper follow-ups, and how are these different concepts and nodes and items related to one another. So I deeply encourage, as you're trying to build, how do I have an AI system that is related and has links to other sources of context that I can follow up on? That becomes essential. Having this relationship graph, this knowledge graph, and the way that we can generate that graph from all of these unstructured documents is we think about that graph data model, and then we think about the documents that we have, and we extract those key fields and terms from those documents, right? Like think about medical examples, like, hey, tell me everything related to pulmonology, tell me everything related to endocrinology, tell me everything related to these key concepts. And then there might be places that reference both. So the intersections of those concepts can be really interesting and can allow you for very deep to understand like very deeply how each of these nodes concepts map back and forth to one another, especially like earlier stage folks trying to understand the interactions. You think about like drug interactions, how they can affect a lot of different systems in the body all at once, right? That's a really interesting place where these relationships can help people understand and explore all of this data that is relatively interrelated, and an expert would have that mental model of how they are related. It's exposing a lot of that to the software side. Batch inference generates that. So I want you to know any data engineering and engineer can use this technology. If you're trying to extract these data, please go and work with AI Query today. It is the fastest, most efficient way of extracting a lot of insights out of your unstructured documents, building compound insights and powering AI systems downstream as well. I I use this, I see this used at dozens of my customers today, and I think it's probably the fastest growing section of AI. But obviously, I have bias. I work at Databricks, one of the leading data companies. So I appreciate everyone's time. I hope you have a great day. Thanks again.